Hi, everybody. My name is Michael Migurski, and I'll be talking to you a little bit about felt.com, a new way to work with maps together on the web. This session kind of has three sections that I'll go through. The first one that I'll talk about is a little bit of history that describes some of the needs that Felt is addressing. So I'll talk about some past work in particular that I've done at past jobs, and some of the ways in which that maybe highlights some of the need for Felt and where it fits into the world. Next, I'll talk about some use cases and flows, in particular how one would work between tools like Felt and QGIS. And then I'll wrap up by talking about some of the open source dependencies that we have, our contributions back to them, and generally how open source is important to us and what are the ways in which we give back to it. Sorry, there's a little mouse wheel here, so scrolling is tricky. A little bit about myself. My role is to work on data product and engineering at Felt. I've been there since last year. The company as a whole is about 2 years old, so quite new on the scene. Prior to Felt, I spent about 4 years at Facebook, now called Meta, and I'll be diving in a little bit to the work that I did at Facebook and some of the relevance it has to the work today. And then before that, a bunch of other things. I was at a company called Remix for several years where we worked on spatial planning tools for urban planners and transportation designers. Worked at MapZen, worked at Code for America, worked at Stamen Design, overlapped with many folks that are here in the audience, although it's actually my personal first time speaking at a FOSS4G International and also my first time at Kosovo, so super grateful for the opportunity. So let's talk a little bit about needs, and I'll start by talking about projects that have nothing in particular to do with Felt, but really illustrate, I think, our way of thinking of what the gaps are that we're filling. And in particular, what do people need when they work on maps in an organization or on a team? And these are all observations from working on past mapping data and products. And they kind of broadly fit into some of these categories. We've observed a lot of missed opportunities and bad connections around spatial work. We've observed that today's open source ecosystem is very well attuned for individual work. It's extremely powerful, extremely convenient for people to use a lot of the open source tools that we see at conferences like this one in their work as solo developers or solo geographers. But we think that there are some painful gaps that I'll talk about for teams and organizations once you get up above the level of the individual. So the example I'll be using is a project called GeoInsights. This is something that I worked on as an engineering manager at Facebook between 2018 and 2021. You can see some of the output of it still today at dataforgood.facebook.com. And I won't get too far into the weeds on it, but if you're curious to learn more about it, actually it plays a small role in Saeed's keynote that he's going to be doing about the Turkey earthquake response on this stage in about 2 hours. So you may see some hints of this work a little bit later today that's informed by some of this work at Facebook. But the kind of gist of this project is that, Facebook had these big, interesting geospatial problems, as you might imagine, for a company with, 2 to 3 billion users worldwide. I personally supported a team of engineers that worked on a tool for analyzing spatial data, and GeoInsights was the name of that tool. So I'll talk a little bit about it and show some screenshots and maybe kind of show how it sort of charted the path towards how we're thinking about Felt. There was a data science aspect to GeoInsights. There was 3 data science PhDs on the team that worked on model creation. One particular one that you can still benefit from today is shown in screenshot here. It's called the High Resolution Settlement Layer, or HRSL, and it's a 30-meter global population grid based on AI and machine learning from satellite imagery that is continually produced by Facebook and Meta in order to show, essentially in very high resolution, where people are settled and where they live around the world based on satellite imagery and building presence. One of the pains and the needs on the data science of this work was that actually, even though these folks are really skilled PhD statisticians, people that are very adept at working with numbers and tools like RStudio, they actually didn't have a whole lot of geospatial knowledge and access to geospatial tools on the team itself. So they were kind of inventing things from scratch in a lot of cases because they didn't really have access to kind of common data sets and tools that they may have learned about in a more GIS-style education. But they were able to produce really fantastic work. This is a screenshot of one of the projects called Movement Maps. The benefit of this project was, because Facebook had some way to observe how populations moved based on mobile telephone pings from Facebook usage, we were able to share that information with humanitarian organizations, in particular in response to various kinds of fast-moving disasters, to be able to show how people reacted by moving away from and back to perhaps crisis-afflicted areas over different spans of time, which could be used in order to direct things like aid relief efforts, that kind of thing. On the engineering side, there was a team of 5 engineers and designers. This is the group that I worked more closely with. And typically what our work was assembling web-based tools, things like Mapbox, PMTiles, into a dynamic application. And the pains there also existed. A lot of them really had to do with the pain of reinventing fairly normal UIs from scratch. Oops, wrong way. There we go. But at the same time, even though we were reinventing a lot of stuff, you could still do a lot of really sophisticated work if you had that scale of team working on, in this particular case, raster data for Facebook usage and other kinds of spatial information about Facebook at a very low level. And then there was a lot of combined pains that came from those 2 teams working together and, again, trying to construct something without necessarily the benefit of a lot of pre-existing spatial knowledge. The data sharing itself was a lot of needlessly custom engineering work. Most of our development effort actually went into permissions control, not even the interesting part of mapping or visualization, but just who could see it and how can you get this data out of the company to partners at the World Bank and other organizations. And then data would also immediately exit kind of what we called map world. Once this data was in use, it would go into slides, PowerPoints, PDFs, Word documents, and was sort of no longer a map at that point. It was no longer possible to think of it as geographic data. It was just kind of pictures of data, so a little bit dead. Another of the big pains that we found, another of the big needs that we saw, was that even though applications like QGIS were clearly available to a lot of these folks, and Facebook in fact has a fairly strong bias towards open source, we actually found that the understanding for why somebody might use this tool, or even ArcGIS, like a commercial product, was actually really poorly distributed through the organization. So if people happened to be exposed to some of these tools, let's say as master's students or PhD students, they would know to use them, but generally speaking, the knowledge was not widely supported. Meanwhile, a lot of more web-based tools were kind of entering the flow at large organizations like Facebook. For example, Google Docs and Figma have set a lot of new user expectations for what a good team-based development or data editing and data sharing tool should look like. So what are some of those expectations? Google Docs makes things like sharing extremely normal and painless. The ability to get data amongst teams, make it available to people who you work with, make it available outside your group. Figma, which is an in-browser drawing tool, approximately sort of the same thing as Adobe Illustrator, but browser-based, introduces this whole concept of multiplayer. If you're a designer working with Figma, you're seeing your collaborators, cursors moving around on the screen. People are able to direct your attention. You can see the thing you're working on together with other people on your team, and it's a very interactive process, even if you're remote from one another. And then tools like Notion, which is kind of a wiki document together commercial product, introduces this whole concept of feedback, commenting as a really core part of the workflow. So these are the kinds of things that people expect now from their tools and that are not necessarily getting from everything out there. So these are the opportunities we see. The benefits of getting real geospatial tools without an individual having to know personally to install them. Some kind of place for shared team assets in perhaps a data library. Some way to collaborate and provide feedback without leaving the map, without going off into PowerPoint land or PDF land. And then if QGIS flows exist already, how do you support them formally? How do you make sure that they're a part of the work that's happening? So this brings us to Felt. This is kind of the space in which Felt operates. Felt fills some of these gaps. In particular, we've seen the importance of QGIS to our users' work. We've found that for a lot of the users that we talk to, they do a lot of their kind of pre-existing analysis and a lot of their more kind of hardcore data operations in QGIS, and then they bring it into Felt where they do the sharing and collaboration and presentation side of the work. So we've really found that where QGIS wins, Felt wins. And I'll give you a few examples of some work that we've seen in that area. Here's an example from Angelica Rodriguez Arriaga, where she put together a QGIS map of top crops in California, divided up by county, but then brings it into Felt in order to get some of the more kind of informal drawing tools built in, such as that call out for San Francisco, some of the stuff for Los Angeles down in the south, things that you may not have in normal GIS apps, but kind of look a little bit more like drawing people's attention to something or kind of more informally annotating parts of the map. Stamen Design used Felt earlier this year to produce a project called the West Cliff Recreation Area. This is a region around Santa Cruz that's threatened right now, and they used QGIS in order to create some of the shaded bathymetry and some other data preparation, but then in the same way, Felt becomes a way to kind of annotate, label, and produce an artifact for sharing. Yao Hua La in Malaysia produced a project called Makaranga with Felt that pulls together different kinds of environmental reports on crops and other uses of land based on a pretty heavy analysis within QGIS. Joe Morrison at Umbra, actually, wow, this is completely invisible. It's quite a dark image, but he's using some of his company Umbra's satellite imagery within Felt to show where perhaps illegal Amazon mining is happening for gold. So Felt is really part of a complete loop here. People are using it together for a complete data preparation, analysis, and feedback flow. I put together an example that I'll step through that works on a data set called TIMS, the Transportation Injury Mapping System, which in California tracks typically car collisions, and in this case, bicycle and pedestrian collisions. So a typical workflow between QGIS Felt might start with QGIS. Perhaps you're pulling in data from a system like TIMS, or in this case, zip codes or postal codes from an organization like the US Census. You're pulling that together into QGIS and starting to do some early analysis, perhaps doing point and polygon counts, in this case showing which of those zip codes had the most or heaviest numbers of cycling-related accidents. We have recently started publishing a plugin to QGIS called Add to Felt, and this makes it a one-click process to bring those two things together. So if you have a QGIS map, perhaps with several vector or raster layers in it, it becomes a one-click process to turn that into a map within Felt. It gets uploaded, and then you get something a little bit like this. Very similar looking, but now you have a whole lot of new affordances that come from this being a tool that's geospatial, but also on the web. So looks similar at first, you can do a lot of styling and so on there, but you can start to get in and do actually some pretty interesting and creative, more like team workflow tasks. Here, for example, maybe I'm commenting on some of these. Maybe I'm using a polygon drawing tool in order to highlight some of those elements. Perhaps I have other colleagues that are looking at this map at the same time and making comments to each other. So this is where you start to get perhaps people that aren't GIS users, or they're not planners, or they're not part of that QGIS workflow, but they know how to work a web browser, they know how to work Google Docs, and they understand how to do fairly basic kind of commenting, interaction. Maybe they can start bringing elements of media or bits of freehand drawing into the map in order to enrich that interaction. So it becomes a kind of common conversational environment where people can talk and share work. And then you can bring it all back out of Felt, pull it back into QGIS, and kind of complete that loop. It becomes sort of a full tool chain where the analysis and the analytical power of QGIS and then that sharing and collaboration functionality of Felt all sort of comes together. So here's the loop. QGIS and its universe of plugins for really complex analysis. Felt has an API and a feature called Upload Anything for bringing that data in. Our UI quickly displays very large data sets in a fast web view. For those of you who were at Erica Fisher's talk about Tippecanoe yesterday, I'll talk a little bit about that tool in a second as well. Sort of maybe you understand a bit more about how you get this kind of speed and performance even for quite large data sets. We have drawing tools for soliciting feedback, generating new data, and then ultimately that API for turning that data back into geodata that can fold its way back into the more analytical-based flows. So I want to close out by talking a little bit about why open source is important to Felt. We are a commercial product, but we actually have a fairly large number of relationships with open source tools that we either use or support or contribute to in various ways, and I'll talk about a few of those. Here's just kind of a few things. We have ones where we contribute code. There's a few that we support really intensely because they're core tools that are very central to what we do. And then finally, we have organizations that we sponsor directly because they're so kind of important in the lives of our users and that kind of feedback flow. So in terms of contributions, MapLibre and GDAL, or GDAL, both feature very, very heavily in our work. We render via MapLibre. For those of you not familiar with it, there are some folks like Yuri and others that are here from MapLibre at the conference. This is a fork of what was originally the Mapbox browser-based and other map rendering SDKs. We use those as our mapping engine for the in-browser display, and we've contributed in the areas of style, raster, text rendering, and other functionality in order to expand and improve MapLibre as a very strong open source project that helps benefit us. We have a similar relationship with GDAL. Our upload anything raster and vector data upload system is almost to be thought of as a very thin wrapper around the power of GDAL. And where we've found opportunities, for example, by expanding support for archive formats that we contributed up to version 3.7.0, we've tried to bring those back into the kind of larger fold of GDAL to improve it for lots of other users. We also have deeper relationships with tools. This is Erica. Erica's in the audience. There she is waving. Tippecanoe, if you weren't at the talk yesterday, is really, I think, one of the only lossy visualization-optimized tiling engines for vector data. Very powerful because it allows you to do things like uploading, let's say, geo packages with potentially millions of rows in them and displaying them almost instantaneously in a web browser because it downsamples, simplifies, and generalizes that data to make it very easy to work with, even as the entire data set is there present behind the scenes. Basically, all of our data passes through Tippecanoe on its way to PMTiles, which I'll talk about in a second. And we've actually picked up its development from Mapbox. Originally created there, Erica joined Felt last year, and we've been issuing new releases after a fairly dry period in Tippecanoe's history. Another core tool that's very, very important to us is PMTiles, part of the ProtoMap suite by Brandon Liu. PMTiles is a new emerging format for tiled data in cloud environments. For those of you who weren't at Brandon's talk yesterday, you'll be perhaps interested to take a look at it as an alternative to MBTiles and a way to think about how cloud-based environments like S3 or other object stores can work with tremendously large tile sets. Again, all of our uploaded user data flows through PMTiles, and we've funded directly some expansion work on PMTiles' ability to read and write in various environments. AWS Lambda in particular is part of our flow, so making sure that PMTiles bytes can be read via AWS Lambda is very important to us. And then making sure, for example, that Tippecanoe is able to write directly to PMTiles. I think I also heard from Evan's talk yesterday that it might be supported in GDAL coming in pretty soon. And then finally, we have some open projects that are extremely important to us and that we actually partner with directly. QGIS is huge for us. Felt earlier this year became the first flagship sponsor of QGIS. This is a 3-year commitment that we've made. And in particular, this helps us to support QGIS with some of the less glamorous, more kind of long-term planning and bug fixing efforts that they have to go through. And we do that because these two projects really complement one another. The workstation-based analysis of QGIS is something that's tremendously important to users of Felt and will remain tremendously important to users of Felt. But then where Felt comes in is that kind of web-based sharing, collaboration, multiplayer, and feedback flows that are important once you want to bring your work outside and beyond your GIS group into something more like public comment, public feedback, members of your team that aren't competent with these tools, that kind of thing. Broadly, we think that when QGIS wins, Felt wins together. So really back to the start, what are some of those needs that I talked about earlier, and then how does Felt and a lot of this open source tooling kind of address that? We talked a little bit about how putting together these low-level visualization tools in projects like the one I worked on at Facebook really forces you to reinvent normal stuff from scratch. So Felt is this complete mapping environment for users and teams right in their web browser. A lot of times, even large organizations like the one that I worked in would not have access to geographers on teams or formal spatial tools. So Felt provides a lot of that in this kind of friendly browser-based environment that's very accessible to teams like that. Data sharing and permissions is very hard engineering work. It's unglamorous, it's difficult to get right, easy to screw up, and Felt does a lot of that directly within the tool. And then finally, there's this issue about data exiting kind of the map world. When data gets dropped out into a PDF, dropped out into a PowerPoint, dropped out into a screenshot in a Google Doc, it's no longer a map, and it becomes very hard to bring that back into that full loop that I described that allows that data to stay geographic and stay part of an actual decision-making or informational workflow. So Felt supports that shared work, and that's kind of a key part of what Felt is offering. So that's it. Thank you, everybody. Very appreciative of the chance to talk to you today about the project, and really happy to catch more talks today and tomorrow at Phosphor-G. And I think we have about 5 minutes for questions. Is that right?
Thank you so much.
Thank you.
All right. Are there any questions? Yes.
Have you considered a more live feedback loop back into QGIS?
Have we considered a more live feedback loop? Absolutely. A lot of our QGIS related releases are very, very fresh. I think the plugin is perhaps a week old at this point. So our strategy generally has been get this stuff out there, start to see what kinds of demands and expectations people have of it once they get their hands on it, and then use that in order to kind of drive the product and engineering and design work that we're doing. And definitely one of the things that we're hearing is a lot of what you are saying. People who have perhaps regularly updated or live updated or otherwise real-time in some form data flows that they want to see happening moving between the two. So we have an API. It's technically possible for people to kind of self-serve on that, but we're also observing how people use that API in order to determine if that's something that we should be supporting kind of first party.
Any other questions?
Yeah, I was wondering, can you use it with touchscreen or a digital pencil?
Can you use felt with touchscreen or digital pencil? I've not personally done it, but apparently you can. I think we have a lot of users that use it on mobile, which to me sort of expands to like iPad type interactions, and it's definitely possible to use it in those cases. It's a web-based tool, so we rely on the kind of affordances of web browsers in order to do that, but it's possible.
Okay, thanks.
Any other questions?
Thank you for talking. I am amazed your application. One question: how do you think about dynamic tiling? Your approach is mainly focused on static tiling in like Tippecanoe or PMTiles. But origin data has once changed. We have to make PMTiles at all. So I think it is needed to tiling in dynamically. What do you think?
I'm actually not sure I fully understood the question. I'm sorry. Would you mind compressing that a little bit?
Yep.
So,
how do you think about dynamic tiling?
Dynamic tiling.
Yeah.
Oh, yes. Generally speaking, the data that people upload into felt tends to be sort of a one-time static thing. So we do use certain elements of dynamic tiling, mostly as kind of like an internal efficiency thing. Don't calculate until you actually need it. But I think kind of as to the earlier question, I think one of the things that we're observing is that we have customers that are interested in the idea of data that changes over time. So our perception is, there's obviously a very easy way to deal with that, which is just upload stuff repeatedly, kind of boring. But I think one of the things we're trying to observe is
I missed it. As far as I understood, it's kind of a tool for like teams and collaboration, and I was wondering if there's also like a use case for extracting like crowdsourcing information, like think of development plans, urban development, and you want to like collect data like from citizens there, maybe also anonymous, extract the like comments and feed that back to the urban planners.
Yeah, that's absolutely a use case that we've observed. So in the kind of broad areas of like architecture, engineering, planning, urban construction, things like that, one of the patterns that we very frequently see is the need for community feedback on plans. So we've seen a number of architecture and related firms, planning firms, essentially use felt to share maps that show different kinds of scenarios or potential plans to people. You know, what if we put this bike lane here versus there? And we've definitely seen evidence of people using it in that way. Our commenting and other features do allow anonymous users or people without accounts in order to participate. So if you set your maps sharing in a way that makes it publicly viewable, you can actually embed it in different places on the web. You can invite people to give you feedback. I think the most sort of extreme example that we've seen is within the last week or so, there's a guy who's doing a walk with his dog across France and using felt basically to encourage people to set up meeting points to meet the dog and pet the dog. And I want to say that it might be the most heavily used in terms of numbers of people map that we've seen on felt today. All of them are anonymous. I think the dog's having a great time.
All right, any final questions? No? Well, thank you again. Ah, sorry.
I don't want to be offensive, but do you plan to make this open source at some point, or?
There's elements of open source that we are making available. So I think, very broadly, there's kind of a, division. There's some things that are very much like pieces of the product that don't really make sense in the open source world, and so we're not considering those. But then there's other elements like our use of MapLibre, the improvements that we're making to Tippecanoe, the improvements that we're making to GDAL, that we try to kind of aim in a direction where they're actually happening down below in those projects that we use, and then pushing them back out into those projects. So things that are kind of, custom to us, probably not. Things that are not custom to us, definitely yes.